Now, in terms of the specific application for RIP routing, a routing policy is required to advertise routes. So the default export policy, which means your routes going outbound, is going to be to allow everything out, but the default import policy is that we are going to, or actually it may be the other way around. I think the import policy is permit, and the export policy is deny. Let's take a look at this on the CLI first. Now, when you go to actually do the configuration, the policy in terms of the routing policy is going to be called from a group. A group is basically a set of interfaces. So one of the most basic configs here would be to create a policy that says we're going to permit everything. So it's not matching anything. The only thing it's doing is saying to accept the routes. Then under protocols, under RIP, we're creating a group. The name here in this case is RIP_group. We're saying to export the routes as permit. So these actually, that should be swapped around. Export as deny and import as permit. And we can see this if we were to, let's take a look at our topology here. And let's say that on our regular iOS router, so on CSR1, CSR2, and the 7200, let's go ahead and enable the RIP process. And we're simply going to turn RIP on all of our interfaces. So on CSR1, we're going to go to global config in iOS, config T, router RIP. We want to run RIP version 2. We don't want to automatically summarize prefixes. And then we're going to enable RIP on anything that starts with 10. And I'm also going to advertise my loopback. Let's say we do redistribute connected and give it a metric value. And we'll show run pipe section RIP, and then basically take this same config and we'll paste it on the other router. So on CSR2, we're running RIP. On our 7200, we're running RIP. In the case of iOS XR, we need to do this on a per interface basis. So if we look at the show IP interface brief, and we'll say pipe exclude unassigned. So only show me interfaces that have addresses as defined. And then I'm going to enable the RIP process on all 4 of these. Okay, so we're going to, I need to add the keyword interface before these. So in XR, we're going to go to global config. We're going to say router RIP, no auto summary. And then these are the interfaces that are running the process. If we look at the show config, this output again in XR, this is the equivalent of show pipe compare in JunOS. So these are my uncommitted changes. So I'm going to save the config, I'm going to commit. And then we will show route IPv4 RIP. And we should see here shortly after RIP converges that we start to get some routing advertisements. So if we look at the other routers, let's say for example on CSR1 and we show IP route RIP, we should, actually that router doesn't have anything connected to it, show IP route RIP. Okay, so CSR2 is getting routes from 36.6, which is, in our particular topology, that is this interface here. Okay, so the 7200 and the CSR 1000V, they're running RIP together. And then we should see that XR1 starts to learn routes from the 7200 as well. Okay, so basically up to this point, we have RIP v2 connectivity this way. Okay, so now we're going to enable it on JunOS. So first, let's look at it without configuring any routing policies. Look at what the end result of what we're advertising, what we are receiving, and then we'll configure the policy to filter what particular routes that we want to accept or to receive. So if we want to, let's say we start on SRX1, we're going to go to config mode. We're going to edit protocols RIP, and we're going to create our group. So we're going to set the group. We give it a name. We'll say RIP. And then the neighbor actually is not the neighbor's address, it's the neighbor's interface, basically the local link that we want to run the RIP process on. So if we say run show interfaces terse pipe match inet, that's essentially the equivalent of what I was looking at on XR, which was the show IP interface brief pipe exclude unassigned. So show me the brief interfaces, but only show me the ones that had IPs assigned. In the case of JunOS, we can do that by grepping inet or matching inet. Okay, so it's going to be these particular links. So we're going to set the group RIP. Neighbor is going to be gigi 00012, 23, and 24. Now, we don't need to explicitly set the loopback as we would in iOS. By default, it's going to include everything for advertisements. Now, we'll see that there are ways that we can control on a per group basis what are the updates that we want to send, what are the updates that we want to receive, and that's going to be based on how we define our routing policy. So if we then top show pipe compare, which again is showing all of our uncommitted changes, we're simply enabling the RIP process on all three of those interfaces. So let's commit and quit. And let's do that on the rest of the boxes in the meantime. So let's say on all of these, essentially, we're going to show interfaces terse pipe match inet. And then these are going to be, let's say pipe match inet, pipe match GE for gig E as well. So only the gig interfaces. These are the ones that we're going to enable the process on. So let's go to global config or config mode, edit protocols, RIP group, RIP we'll call it, and set neighbor. Actually, let's edit neighbor. Actually, we can't do that. Let's say set neighbor, and then these links. 35, 45, 56, 58. Okay, same thing on the other one. So let's say, let's look at the full syntax. Let's say show config protocols pipe display set. Okay, so that's our full syntax expansion. So we will, from config mode, set protocols RIP, group, RIP, neighbor, and then the link. Now, the group name itself is locally significant. It doesn't have to match between the neighbors, but for simplicity here, we're just using the same value over and over and over. So commit there. Same thing on the other one. Let's say exit config, show interfaces terse, pipe match GE, pipe match inet, config. And we're going to set this on gig 89. And then here we have 24, 34, 45, and 46. Okay, now on the iOS side, let's say, for example, on CSR1, let's turn debugging for the RIP process on. So on CSR1, just from exec mode, let's simply say debug IP rip. Okay, this should show us both the inbound and the outbound routing advertisements that the RIP process is going through. So these are going to be periodic updates. They're going to be about 60 seconds by default. And then, of course, in JunOS, just like we can in iOS, you can tune all of these individual parameters. Where you would normally do that is going to be under set protocols RIP, under the group, and then under the interfaces. That's where you would configure your individual timers. Or do you want to enable RIP on the interface? Do you want to listen just passively? Normally, that's going to be configured on the link level. So we can see from CSR1 that we are sending RIP updates out, but right now we're not receiving anything. So if we look at the other side, if we look at SRX1, and let's look at the show RIP neighbors. we can see that we are receiving RIP updates in, and well, technically it doesn't show that we're receiving updates. It just shows that, well, these are the links that we're running the RIP process on. We're using the RIP v2 multicast. Receive mode is both, so we're listening for both broadcast and multicast updates. Our inbound metric is 1 for offsetting the hop count, which of course you can modify pretty much all of these options. But if we look at the show route protocols RIP, we can see that we're receiving updates inbound, but if we look at from the iOS side and we show IP route RIP, we're not advertising updates out. So again, the default behavior is that without a routing policy configured, you allow updates to come in, but you're not going to send any of them out. And this is specific to the RIP process. We'll see BGP is going to have different defaults than this. OSPF and ISIS, normally you don't configure a routing policy because those are link state protocols and you cannot do inbound filtering because basically that would break the database synchronization. But in the case of RIP, since it is a distance vector protocol, we can enforce filtering or summarization at any arbitrary point in the topology. So specifically what we need to do then here is to configure the routing policy. So let's configure a basic policy first that is just going to allow everything. So we'll go to config. We're going to edit our policy options. We're going to edit a policy statement, and we'll call this just permit. And we're not going to match anything. We're simply going to just say set, then accept. So I'm not matching anything. I'm just saying whatever it is, then I'm going to accept it. And we'll top show pipe compare. This is basically the simplest policy that you can have. Okay, then under the RIP process, if we top show protocols, there we have the config for the RIP process. So let's go top edit protocols RIP. Okay, that's going to move us to the RIP process. We're going to edit group RIP. And then we're going to set what is the import or the export policy. Now, as I mentioned, in the case of RIP v2, the import policy is to permit everything by default. What we need to define is the export policy. So what are we advertising outbound? So we're going to set export, and then we can see we have the name here is permit. You can use the tab to complete it. Then we'll top show pipe compare and commit and quit. So assuming this correctly applies, what we should see then is on the iOS side, on the connected link, we should start to receive these updates inbound, which we do. Okay, if we look at the show IP route RIP, on the iOS side, that's the equivalent of the show route protocol RIP in JunOS. If we then look at what did we actually change, let's say show config policy options pipe display set, and show config protocols RIP pipe display set. Basically, it's just these two statements. So when you look at it in the stanza format, you can see it's expanded a lot further, but it's technically only 2 commands in order to do this. So I'm going to take these 2 commands, we're going to put it on the rest of the routers, and we should see that they start to advertise everything then. So we'll tell them to go to config mode, set the policy statement, edit RIP so that the group is the policy statement is applied to the group, and then we'll save the config. Okay, so that applies to all of them. Okay, the end result should be, if we take a look at the iOS side, and let's undebug here, undebug all, and show IP route RIP, we should see that we're going to learn the loopbacks of all of the routers, where if you take a look at the logical topology, basically the routers are numbered here 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that's what this device table is talking about up here. And when we're looking at the loopback addressing, it's basically the router's number as a host route. So device 1 has the address 1111/32. Device 5 is 5555/32. So when we're doing our verifications here, it'll make it a little bit easier in the topology for us to see who is working or who is not working. Who do we have connectivity to? So if we show IP route RIP, 2, 3, 4, 5, 6, 8, and 9, not 7, whose 7 is SRX3. Let's show route protocol RIP. And that may just be converging. Let me check that again. No, it's not enabled there. Let's see, does anybody else have this? Let's say on the 7200. Show IP route RIP. We have the update here. So let's see, it should be going from SRX3 to the 7200 to CSR2. Let's show IP route 7777, which it does have it. It's probably just converging. Show IP route 7777. Let's see, does SRX1 have it? Let's show route, and then just the exact route, 7777. There we go. Okay, so it's just slow to converge by nature, RIP is. Okay, so essentially it's just a couple different commands in order to start the process. Let's look at this again. If we show config, and we need to show config policy options, and show config protocols RIP. So we're saying regardless of what the route is, we're going to accept it. This is applied to our outbound updates, and then this is applied on those specific interfaces. Now, if we look at what are the other options that we have under here, if we go to config and edit protocols, config, edit protocols RIP, group RIP, and edit the neighbor, like gigi 000.12, this is where we would set any of the link level type options. Like, for example, if we want to do bidirectional forwarding detection, that's the equivalent of enabling BFD under the link in iOS. If we wanted to do clear text or MD5 authentication, where we specify the authentication key and type, what are we going to receive in from the neighbor? So if we were to say set receive, what versions do we want to run? When we're sending updates, do we want to send them as broadcast, multicast, or as version 1? So assuming that you understand how the protocol works behind the scenes, the features are almost on a one-to-one basis between iOS and JunOS. It's just that the syntax, of course, is varied between them. So really, you'll see that if you really understand the protocols from their core functionality point of view, there's not a whole lot of that is changing between the platforms. It's mainly just the syntax interface, how we are enabling, how we are verifying the particular protocols. Okay, so let's take a look then at a basic example of modifying the routing policy. So as it stands now, we're basically accepting and receiving everything. If we look at the run show route, we see that we have all of the loopbacks. The loopbacks are /32s, and then the transit interfaces between the routers, those are the /24s. Okay, so let's say, for example, that on this particular bus, on SRX1, that when we are advertising routes outbound to the CSR, so as we're going in this direction, let's say that we only want to advertise them the host routes. We want to give them just the /32s. Now, we can, of course, match it based on the specific prefixes. So we could say match 2222/32 and then allow this outbound. Or like in iOS, we can also do this based on ranges. So there's a couple different ways that you can apply it. You can apply it by creating prefix lists and then calling the prefix list from inside the routing policy, or you can do it directly inline in the policy, similar to how you can in iOS XR's RPL. Where this is going to be defined is going to be under the policy options and then under the policy statement. So under policy options, if we look at the set, this is where we have a prefix list. So if we were to say set prefix list, and let's say that this is going to match, let's say CSR2 loopback. And that is going to match the prefix, which is CSR2's loopback, is 3333/32. So let's say it's matching that exactly. Set 3333/32. Then we're going to use this in the policy statement. So we're going to edit a policy statement. We'll say advertise CSR2 loopback. We're going to edit a term. Edit term. We'll say permit CSR2 loopback. Says set from our prefix list. Set from prefix list. Prefix list name was CSR2 loopback. If that is true, what do we want to do? Set then accept. Then we'll have another statement. Let's say top show pipe compare. We're going to have another statement that is edit term. Actually, where are we? We are under that term, so we need to go up one. We'll edit, let's say deny all. Edit term deny all. That says set reject. Set then reject. Top show pipe compare. Okay, so what this is essentially saying is that we're first checking is the route in this particular prefix list. Okay, prefix list is saying 3333/32. So is it exactly that route? Okay, if it is, then I'm going to accept it. If it goes down to the next statement, which is deny all, I'm not doing any match, I'm just rejecting. So everything else is going to be denied. And you can see clearly what is the sequence of how it's going to be processed based on how it's indented in the stanzas. So this term is first, then we go to that term, and then we have everything else, which is essentially nothing because we're doing an explicit deny. So let's commit that change first. Then we're going to top show protocols RIP, and we're going to top edit protocols RIP. And what I'm going to do here is now create a new group that is going to apply just to that particular interface. So in the case of iOS, this would be us applying a prefix list as a distribute list out a particular interface. But in the case of JunOS, we have to group them, we're grouping the interfaces together based on this group. So if we want to apply one filter differently to one link than another, we need to apply them in a separate group. So I'm going to set a group. And we'll say that this is our advertise CSR2 loopback group. And we're going to set the neighbor to that link. And we're going to, I wanted to edit that. Edit that group. We're going to set the neighbor. And set the export policy to be advertise CSR2 loopback. If we then top show protocols RIP, this interface is now going to move down to the other group. Okay, so I need to remove it from this old one. If we do a commit check, I believe it's going to reject this because it shouldn't be in multiple groups at the same time. Yes, it's already in a group. So we need to go up one. We need to edit group RIP and then delete neighbor gig E00012. Okay, the top show pipe compare. Then commit and quit. So what we should see now, assuming that the policy is actually going to apply, if we go over to CSR1 and let's debug IPRIP, we should now see that for our inbound updates that we're receiving on the iOS side, the only thing that it should be including is that one particular prefix, which if we show config policy options, should be 3333/32. Which we do have it. So if we look at the show IP route RIP from the iOS side, all of the other prefixes are going to get denied. So eventually the rest of these should age out. You should be able to see this based on the age of the route in the routing table, where the default update interval for RIP is about every 60 seconds. So any updates that go beyond this timer basically means that these are aging out. Okay, so this is the only one that we're receiving. Now, of course, the logic of the policy can get a lot more complicated than this. You can match criteria, and then you could say go on and continue to the next statement. But you'll see that the vast majority of granular policies are going to be the ones that you would apply for BGP policy application. So for inbound, outbound traffic engineering, for filtering, both in unicast, for IPv4, IPv6 unicast, MPLS, in the case of L3 VPN applications, also for multicast routing, if we're using multi-protocol BGP to advertise our multicast routes for the purposes of reverse path forwarding. So it's the same type of logic as iOS, but of course the syntax format is different as to how we're applying it. Okay, so let's look at our full config then. Let's say show config, pipe display, set. And let's say accept system, pipe accept. Let's just try that. So in reality, it's not that many commands in order to do it, but the hierarchy of it is pretty complicated. So 3 different statements. This one is just saying for the neighbors that are in these 2 interfaces, we're going to send them whatever. For the neighbor that's on this link, we're going to send them what's in this policy. This policy says if it's that prefix list, we're going to allow it. If it's anything else, then we're going to reject it.